at midpoint and distance, the pre-AP version. First thing we can do with midpoint is find a midpoint between just 2 points. So if you're looking to find the midpoint between 3 and 5, that is the coordinate between 3 and 5, we'll use a variation of the midpoint formula. We'll add these two numbers together and we'll divide them by 2. So 3 plus 5 is 8. 8 divided by 2 is 4. So 4 is the midpoint between 3 and 5. All right, we do the same thing with -7 and +4. If we add them together and divide by 2, so -7 and +4 is -3, and -3 divided by 2 is -1.5. So -1.5 would be the coordinate that is equidistant from -7 and +4. Okay, same thing with number 3. Find the midpoint between 5 and 9. Add these two numbers together and divide by 2. 5 plus -9. 5 and -9 add up to -4. -4 divided by 2 is -2. So finding a coordinate between 2 points, or the midpoint of the coordinate between 2 points. Realistically, in this class, we're going to be using the midpoint formula. We'll be finding the midpoint between 2 coordinates on a coordinate plane. So you'll notice that we have the point A and the point B. We got to take A and B and plug them into the midpoint formula. So the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Pretty much double what we just did. So be careful you're putting the right information in the right spot. I'm going to call A my x1 and y1. I'm going to call B my x2 and y2. So we're calculating the midpoint between A and B, a point that is exactly between them. We should get a coordinate location. 6 plus 4 divided by 2, comma 7 plus 3 divided by 2. So that is the answer. It's not written in a simplified version. 6 plus 4 is 10. 10 divided by 2 is 5. 7 plus 3 is 10. 10 divided by 2 is 5. So the coordinate of the midpoint is the point 5, 5. All right. Same thing with number 5 over here. Find the midpoint between A and B. We have x1 and y1. We have x2 and y2. We add our x's together. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So -1 plus 2 is +1. 5 plus -3 is -2. And we can clean this up just a little more by saying 1/2, comma -1. And it is acceptable to have fractions as your midpoint answers. So all we're doing is calculating the point exactly between 2 points, or the midpoint between 2 points. So just more practice here. As you become more and more proficient with this stuff, you guys can start taking some shortcuts. The midpoint between A and B, 14 and 7, with -2 and -8. So 14 plus 7 is 21. 21 divided by 2 is 10.5. -2 plus -8 is -10. -10 divided by 2 is -5. All right. So the last version of this is finding another endpoint. So in this scenario, I'm giving you one endpoint and one midpoint, and it is your job to find the other endpoint. So it says M is the midpoint of line segment TL. So I have line segment TL, and I know that M is exactly in the middle, so that this piece equals this piece. What I'm going to do is kind of make a number line here. I know that T is at the location 6, 0, and M is at the location 0, 2. So in order for this to work, the distance from T to M has to be the same as the distance from M to L, because M is the midpoint. So if we kind of force the same distance on top and force the same distance on bottom, it should work out. How do I get from 6 to 0? I do that by subtracting 6. So if I repeat that process and subtract 6 again, 6 minus 6 is 0, 0 minus 6 is negative 6. Same thing here. How do I get from 0 to 2? Plus 2. And then again, plus 2. 2 plus 2 is 4. So the other endpoint L is at the location negative 6, 4. That keeps the rate of change consistent from endpoint to midpoint and midpoint to endpoint. So the same thing over here on number 2. We have the same line segment TL, and we have midpoint M. So I know those two line segments are congruent to each other. C is at the point negative 3, 6, and M is at the point negative 1, 4. So to get from negative 3 to negative 1, I added 2, so I have to repeat that, add 2. To get from 6 to 4, it's subtract 2, so repeat, subtract 2. So L is at the point 1, 2. So that's another way to use midpoint to find more information. And the last one is a fractional distance. It says we have the points J and K, and J is at negative 3, negative 7. K is at the point 5, 2. So we're looking for what is the coordinate of W, which is 1/4 the distance from J to K. So I'm going to use kind of the same technique I used in the last problem. I'm going to draw JK. And I'm going to label it the same way I did. So J is at negative 3, negative 7, and K is at 5, 9. W is 1/4 the distance from J to K. So 1/4, 2/4, 3/4, 4/4. W is right here. I need to find its coordinate location. So the way I'm going to do this is calculate the distance from J to K on top. How far is it from J to K in the X value? So to get from negative 3 to positive 5, that is 8 units away. And then I'm going to calculate 1/4 of that distance times 1/4. 8 times 1/4 is 2. Do the same thing on the bottom. To get from J to K on the bottom is 16 units away. 16 times 1/4 is 4. So on the top, if I go 2 units from J, so negative 3 plus 2 is negative 1. And on the bottom, if I go 4 units from J, negative 7 plus 4 is negative 3. That gives me my coordinate location of W. Now if I keep going, I should end up at point K. I did plus 2, plus 2, plus 2, plus 2. So there's a consistent gap between each coordinate. On the bottom it's plus 4, plus 4, plus 4. So 1, 7, 1, 5, and 9. All right, let's try that one more time. We have points J and K, they're at the same coordinate location, and we're looking for point R, which is 3/4 of the way from J to K. So we could go back and cheat on the last one that we did, and R should be at 3.5. Let's calculate it just to make sure. J and K at the same points, -3, -7, 5, and 9. 1/4, 2/4, 3/4, 4/4. We're looking for point R, which is 3/4 of the way from J to K. So if I find the distance on top, this is the X values from -3 to -5, that's +8. On the bottom, -7 to +9 is 16. I'm gonna apply the distance or the fractional distance, so multiply each distance by 3/4. Let's see, 8 times 3/4 is 6, and 16 times 3/4 is 12. So I have to go on top from -3, I have to add 6 to that. So -3 plus 6 is +3. On the bottom, I have to go from -7 and add 12 to that. -7 plus 12 is 5. So R is at the coordinate location 3, 5. Same thing we got last time. All right, so to switch gears now, the distance formula. Guys, with the distance formula, you should be able to do this mentally, but a calculator will really speed up your process. So the distance formula, there's a lot of different ways to do this. Let's just go through a straight up calculation first. It says find the distance between point A and B, if necessary, round to the nearest tenth. So you guys will have to read the instructions, and it'll say either round to the nearest tenth, or it will say simplify your fraction or simplify your radical. The biggest thing here is just making sure we keep the right signs and don't make any mistakes. I'm going to label my points x1 and y1, x2 and y2. I'm going to plug them into the distance formula. The square root of x2 minus x1 plus y2 minus y1 squared. Okay, at this point, if you have a calculator, you can just go straight to the calculator and type that in. We're gonna hand math it real quick and double check our work. So you're gonna math inside the radical. 6 minus 1 is 5 squared, plus 16 minus 4 is 12 squared. 5 times 5 is 25. 12 times 12 is 144. Add those two numbers together, 169. So I have to figure out, can I take the square root of 169? You can check your calculator if you need to. I know the answer is 13. So 13 is the distance between those 2 points. Let me get this sorted out here real quick. You can also just type this into your calculator, and it should give you the answer. 6, 1, 16, 4. Control the square root of, type in exactly what you see, parentheses 6 minus 1, close parentheses squared, plus 16 minus 4, open parentheses 16 minus 4, close parentheses squared. If you hit enter, you should get 13. Boom. So using the distance formula either by hand or in the calculator. So we can say that the distance from A to B is 13 units, or that line segment AB is 13 units long. The length of AB is 13. There's a lot of different ways to describe this. It does say to the nearest tenth, so technically that would be the correct answer. Again, right, so just find the distance from A to B. Watch out for this one. It has a negative in it, so that might complicate some of your calculations. So x2 minus x1 squared plus y2 minus y1 If you don't put those numbers in the right spot, no chance. So you have to slow down and make sure they're in the right spot. As you become more and more confident with this, you guys can start skipping quite a few steps. 1 minus -3 is 4. 4 squared is 16. 6 minus 2 is 4. 4 squared is 16. 16 plus 16 is 32. So it says round to the nearest tenth, or you can simplify that. Maybe I'm going to go ahead and say that it's going to be 4 square roots of 2. And let's double check our math here. Let's see. The square root of 32 is 5.656. So our answer rounded to the nearest tenth would be a 5.7. 5.7, and I'm going to double check my radical here for square roots of 2. Same thing, either way. So any one of those answers would be accurate. The distance from A to B is 5.7. The length of AB is 4 square roots of 2, or AB is the square root of 32 units long. All those numbers mean the exact same thing. They're all just written in different formats. So using a graph, hopefully you guys might start to see some patterns here. If I was going to calculate the distance from the blue dot to blue dot, it says find all the lengths of all the sides. So you can count the bottom, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. But you have to calculate the hypotenuse. You have to calculate that red line. So you have to take these numbers and you have to plug them into the distance formula. I'm going to use I'm going to use the negative numbers as my x2s and y2s. So -4 minus 4 squared plus -3 minus 3 squared. -4 minus 4 is 8. -8 squared plus -3 minus 3 is -6 squared. Well, hold on. So the distance formula is just a very fancy version of Pythagorean theorem. Okay, this is a squared plus b squared equals c squared, and you take the square root of that to get your answer. So the Pythagorean theorem is the same thing, okay, but they take the square root of both sides, and that's how you get the way it looks different. -8 times -8 is positive 64. -6 times -6 is positive 36. That's the square root of 100. So 10. That means that this line is 10 units long. Alright, so Pythagorean theorem and distance formula are the same thing. I'm going to kind of cut it short here. That should be more than enough for you guys to be successful in your assignment today. Hopefully this video did well.